Till now, we have understood the Cartesian product of sets, and now we are continuing from there only. First, we again repeat what we did in previous class. That is the Cartesian product. Let A equals to 1, 2 and B equal to 4 and 2. So now first we'll find A cross B, means the Cartesian product of A and B. Then this will be 1 comma 2, 1 comma 4, 2 comma 2, 2 comma 4. Now this is the Cartesian product of two sets. Now we know what are the subsets of a set. So we will try to write all subsets of A cross B. So you know that there are the number of subsets, the formula of number subs. I'm writing the formula number of subsets of a set A which has n elements. Number is equal to 2 to the power n. So this is the formula to find the number of subsets of a given set. So now if I ask you to find the number of subsets of A cross B, then you have to count how many elements are there in A cross B. So 1, 2, 3, 4. So it means that in A, if I want to find the number of subsets of A cross B, then there will be 2 to the power 4, that is 16. So in total I'll get 16 subsets of A cross B. So now I'm starting with, let's say the first I'm writing the first subset as, that first all singletons can come. So this is 1, 2, the first set, then 1, 2, then you can take 1, 4 also, 1, 4, and then you can take 2, 2 also, then you can take 2, 4 also. So these all are singleton sets. So these singleton sets, similarly there will be subsets of in which there will be 2 elements. So I'm taking another subset, let's say this 1, 2 and 2, 4. So this is another subset. So similarly there will be total 16 subsets of A cross B. Now what I'm going to do, I'm going to represent that subsets in some you can see that arrow diagram. What is arrow diagram, and what is these subsets can be told in other language. See this subsets, let's say this is subset 1, this is subset 2, this is subset 3, this is subset 4, and say this is subset 5. So I'm writing this A5. A5 is a subset of A cross 5. So see, I am using Venn diagram, arrow diagram. This is called arrow diagram. You see the first arrow diagram means this first one element is 1 and it is related to 2. Second element is 2. You write this 2 here, and this is related to 4. So that subset can also be shown with the help of arrow diagram. This is called arrow diagram. So what is this arrow diagram? In total we'll discuss everything one by one. You see this is the set A and this is your set B, and this A5 is a subset which is defined from set A to set B, you can say. So this subset A5, we have another name of this subset. We can name this subset as relation. So I can write that also as relation R. I can say this as relation R, and I can also write this 1, 2 and 2, 4. So in chapter 1 we were just discussing subsets, but here we are going to give the new name to subset. The name is relation. So relation, here you can say this is relation 5, and You see, this is your subset first, so we can say this is your relation 1, this is your relation 2, this is your relation 3, this is your relation 4, and similarly there will be more relations. So you see, I can write that one more relation. Let's say this relation number 6, it can have three elements: 1 2, 2 4, and 2 2. This is the another subset I have named as A6, and this can be named as R6 also, because it is just the notation that we are using. A6, when we are writing A6, we are understanding this as a subset. When we are writing this R as R6, then we are considering this as a relation. So this is 1 2, 2 4, 2 2. And now this relation, if I want to show through arrow diagram, then it can be shown like this. This is 1 going to 2, and 2 is also going to 2, and this is 2 is also going to 4. So you see, this is again shown with the help of arrow diagram. So this is very clear from the arrow diagram, that is that 1 and 2 have a pair, 2 and 2 have a pair. You can see that 1 and 2 have a pair, 2 and 2 have a pair, and 2 and 4 have a pair. So this way, this with the help of this arrow diagram, it's something that you can visualize. Here this elements are written uniquely in you can see this is the roster form, and this is something the visualization that you are doing, and this is called the arrow diagram. As you have done sets also in with the help of Venn diagram, similarly the relations are also shown with the help of arrow diagram. Now important thing is that this is your A and this is always your B, and this relation I have defined this as R6. There are few important things that you have to understand. These diagrams, normally we also say the mirror diagram also, because the one has image 2. You see, you take this B as a mirror, and these are the original ones. If one is standing here, some image is there in this mirror, so one image is 2, and 2 image is also 2, and 2 image is also 4. You can see the mirrors are of different types. Different types means you stand in some of the mirrors, your face will be looking like looking different from what you are exactly. So this is also the different type of, this is one of the mirror of different type, in which one is looking as 2, and 2 is also looking as 2, and 2 is also looking as 4. So this is also called the mirror diagram. And here this is important that these arrows shows that image of 1 is 2. So I'm going to write this: image of 1 is 2. Similarly, image of 2 is 2 and 4. So you understand that image is something going from this side to this side. And in other way also you can understand, this is the mirror image and this is the original one. So in other way we can say this, that 1 is a pre-image of 2, and this 2 is a pre-image of 2 and 4. So this way you can write this is the image of these element, and these are the pre-images of these elements. Now come to another thing. Now we are going to understand what domain is. See, you can see all these elements have relations, like 1 has relation with 2 and 2 has relation with 2 and 4 both, and this is you can see this one thing. And here also you see the first elements of ordered pairs. This is the first element 1, this is the first element of second ordered pair 2, this is the first element of the third ordered pair. So all these first elements are called domain. So 1 2, we cannot repeat the element, so domain here will be your 1 2. You can do this with the help of two ways. First way is, you see R6 in written in roster form. So roster form, all pairs, you can see there are three pairs. So all first elements will be the element of domain. So domain is your 1 2. Here, from here, if you want to see, then all this you can see this one has relation, two has some relations. So all these elements which has relations on this side, right hand side, they all come in domain. Next is your range. Range means this one has image to all images. You can say all images are, if all images are put in a set, then that set will be called range. I am repeating my words. If all images are put in one set, then that set will be called range. The another way, this is the with the help of this arrow diagram you can understand, and this way also you can understand. If it is relation is written in roster form, this second elements, here it is 2 4 and this is 2, so all second elements are actually constituting the range. So 2 and 4 is the range. Now the third thing is about the codomain. Codomain is your B. So codomain, this is always the right hand sides, the mirror you can see, or this is the oval shape that you are seeing. All the elements in the set will be called codomain. So your codomain is B in this particular case. But in general, this is not the case that codomain and range will be equal. They have this relationship that range is always contained or equal to codomain. So this is another very important relation, and we will take examples to clarify all these concepts with the help of some given questions. So but understand all these basic things, that domain, what is, I'm just repeating my words again. Domain means all first elements of the ordered pairs. All first elements of the ordered pairs are domain, and second element of the ordered pairs are in range, and this complete set, this is called B. This is here B, and this is called codomain. And next important thing is that range can be equal to or can contain in codomain. Means range is the smaller set of, you can say smaller set than codomain, and you can also say range is a subset of B. So that is better if I say that range is a subset of B. So this is what the basic things that you must understood till now. Now we'll discuss something more related to this with the help of some examples. Now we'll take this example number 1 of exercise 2.2. A is given 1 2 3 4 up to 14. Define a relation R from A to A. It means if I make the oval, the first oval and the second oval, this is from A to A, this relation R, here it is, they are saying this relation is R, so this is from A to A. Next, how this relation is defined, you see that R x comma y is your 3x minus y equal to 0, where x comma y belongs to A. Now you see this this y, actually all this, whenever you get a relation, all y will represent this, that they are the element of this codomain, and y particularly the answers that you are going to get, this will be your range element. Now 3x minus y equal to 0, where x comma y belongs to A. So I am using this with the help of this arrow diagram. See, the first element of A is 1. Now you put this value in this relation. So x means the element of A. So you put here then 3 into 1 and equal to y. You can write that relation as, you can also write y equal to 3x. So according to this relation, you see that if you put x equal to 1, then your answer will be 3. And if you put 2, your answer will be 6. And if you put 3, then your answer will be 9. If you put 4, then your answer will be 4 3 ja 12. And if you put 5, then you see, if you put 5 here, then answer will be 15. But this is A, and you can see that A has only 14 elements, so this 15 will not come in A. So but A, you can see this is 1 2 3 4. This is I'm writing with different color so that you can see some difference. This is 5 6 7 8 9 10 11 12 13 and 14. So these all 14 elements are in A. Similarly here also, 1 2 3 has come, 4 5 6 has come, 7 8 9 has come, 10 11 12 13 14. So you can see here are some elements and here are some elements, but important thing is that you can see there are only 4 elements which has some relation with other elements. These arrows are showing that 1 has a relationship with 3, 2 has a relationship with 6, 3 has a relationship with 9, and 4 has a relationship with 12. So when you draw this arrow diagram, it's really helpful to you to analyze or to understand what are its domain, what are its codomain, what are its range, and what are the images of. So let's start with, because they are asking us to write domain, codomain, and range. So we'll start from the domain. Always better you start with domain. As I told you, the domain, all these elements which has the relationship with other elements. So you can see these arrows connection. So this left hand side elements of these arrows will be the elements of domain. So your domain will be 1 2 3 and 4. In another way, you can also say that domain is a subset of A. You can see that domain has only 4 elements and A has 14 elements. So domain is a subset of A. Now next is your range. In range, we always take the images of these elements. First you write domain elements and you see what are the images of these elements. So you can see that one image is 3. So 3, and 2's image is 6, 3 images 9, and 4 images 12. So only these 4 images are there. So all these images will be making the set which is called range. Now come to codomain. Codomain is this complete set. It is defined that relation R is from A to A. So codomain will be completely your A, or you can say this 1 2 3 up to 14, or you can say this is A. So I think you have understood what are the important things about domain, about range, and codomain. So domain means never like this is the complete domain. Only elements of A which has some relations with other elements, and this relation is given to us y equal to 3x. Sometimes this relation is easy to define or easy to understand what is the relationship. Sometimes it's not that can be easily understood or can be defined directly with some relations. So you can see what are the whatever is you can see the images. These all images are the range. That's it. Now we can discuss some more thing, like if I ask you the image of 2, so your answer, you just see what your answer will be. And if I ask you image of 4, then what will be your answer? And next part I can ask you what is pre-image of 4 of 6. So now we will discuss this image of 2. You can see that image of 2 is 6. So image of 2 is 6, and image of 4 is, you can see this relationship 12. So this is 12, and they are asking what is the pre-image, means 6 is there, and 6 is whose image? 6 is 2's image. So you can say that 2 is a pre-image of 6. So this is the first question. I feel like I have made you clear what is domain and range and codomain. With the help of this example, we'll take more examples, but you keep have pace with all these examples. Now see, this is question number 2. define a relation R on N. N means natural numbers. Natural numbers. So that relation R is on N, and it is defined by R x comma y and y equal to x plus 5. And x is a natural number. It is also, they are defining the domain also now this way, that x is a natural number and less than 4. So I'll use this diagram, arrow diagram, and this is always helpful. If you also draw, your things will be much better than others. This relation, this is R. This relation is given from natural number n to natural number n. And what are the elements that x can take? X can have the values, because it is mentioned that x is a natural number and it is less than 4. So it means that x can be 1, it can be 2, it can be 3. Now we see relationship is given to us y equal to x plus 5. So we'll take x equal to 1. Then your y will be, these all, here it is all x and here it is all y. So x means domain and y means range. So 1, you can see that 1, if you put here, it will be 6. If you put 2, then it will be 5 plus 2, 7. If you put 3, then it will be 3 plus 5, 8. And this way you have shown the arrow diagram. Now they are asking you to find the relationship in roster form. So roster form, nothing, just you can write this roster form. 1 is related with 6 and 2 is related with 7 and 3 is related with 8. So this is the roster form. And now we can write domain, because they are asking us to write domain. They are asking us to write range. So we can write domain as 1, 2, 3, and range, you can see all the images as 6, 7, 8. Though they have not asked the codomain, but we can discuss here the codomain also. Your codomain will be this complete set, which is your n, natural numbers. So this is the way you can define domain, range, and codomain also. Let's discuss some more examples.